Bismillahirrahmanirrahim. This is Unit 14, Current Electricity, and we are solving numerical problem from 1 to 5 in this video. Physics 10 National Book Foundation. Question number 1. 12 volt is applied on a copper conductor of resistance 6 kilo ohm. Find the current passing through it. How much charge passes through its any cross-sectional area in 1 hour? So the problem's circuit diagram can be given as there is a voltage source giving 12 volts. The resistor is 6 kilo ohm. We need to find this current passing through the resistor. Now the given data is voltage is equal to 12 volt, resistance is equal to 6 kilo ohm, that is equal to 6 into 10 power 3 ohms. Time is equal to 1 hour, which is 60 minutes times 60 seconds is equal to 3600 seconds. Now we need to find current I passing through the circuit and the total charge passing through any cross-sectional area in 1 hour time, that is 3600 seconds. The formula that we will use is V is equal to IR, that is Ohm's law, and Q is equal to I into T. Now the solution is, from V is equal to IR, find the current I as I is equal to V over R. Substitute V is equal to 12, R is equal to 6 into 10 power 3. I becomes 12 divided by 6 into 10 power 3. Calculating this results in 2 into 10 power minus 3 ampere, or I is 2 milliampere. That is 2 milliampere current will flow through this resistor. In order to find the total charge passing in 1 hour, use Q is equal to I into T. Substitute I is equal to 2 into 10 power minus 3. T is equal to 3600 seconds. So 2 into 10 power minus 3 multiplied by 3600, that results in 7.2 coulombs. Question 2. During lightning, 15,000 ampere current is established when 40 coulomb charge passes through a tree due to potential difference between clouds and ground of 1000 volt. What was the duration of lightning bolt? Find power of the lightning bolt. Now given data is current that passes through the tree 15,000 ampere and charge is equal to 40 coulombs. Now we know that current is rate of flow of charge per unit time. For this 40 coulomb of charge, 15,000 ampere has passed. That means the time must be very, very small, very, very short time. So we will calculate and let's see. To find T, the formula that we will use is Q is equal to I into T. Now solving for time, T is equal to Q over I. We'll move this I to the other side and divide it there, and that becomes T is equal to Q over I. Now the solution. Substitute Q is equal to 40, I is equal to 15,000 ampere and T is equal to Q over I. So T is equal to 40 divided by 15,000. Calculating this results in 2.67 into 10 power minus 3 seconds. This is a very small time, or it can be written as t is equal to 2.67 milliseconds. To calculate power of the lightning bolt, you need the current I 15,000 ampere and the potential difference V is equal to 1000 volt between clouds and the ground. Substitute I and V in the formula for power. P is equal to IV. That means P is equal to 15,000 into 1000. That multiplication results in 15 and then it is followed by 6 zeros, watts. So P is equal to 15 into 10 power 6 watts, or it can be written as P is equal to 15 megawatts. Question 3. Diameter of a copper wire is 7.360 mm. Find the resistance of a 5 kilometer length of such wire used for power transmission. Specific resistance of wire is 7.20 into 10 power minus 8 ohm meter. Now the given data, diameter D is equal to 7.360 mm. We would need to radius in order to calculate the area of the wire. So therefore we calculate the radius from this diameter right here, and radius is equal to half of the diameter, that is dividing diameter by 2. This returns in 7.360 divided by 2 is equal to 3.680 mm. Now convert radius R in meter. So R is equal to 3.680 divided by 1000 results in 3.68 into 10 power minus 3 meters. The given length L is 5 kilometer, that is 5000 meters in System International. Specific resistance of the copper is rho is equal to 1.720 into 10 power minus 8 ohm meter. That is also given to us. Now we need to find the resistance R. The solution. The solution for the resistance requires the specific resistance rho, the length 5000 meter, and the area of the wire, cross-sectional area. Now first we will calculate the area to be inserted in this formula. Now first calculate the cross-sectional area of the wire. A is equal to pi r square, that is the formula for the circular cross-sectional area of the wire. Substitute r is equal to 3.680 into 10 power minus 3. So area becomes pi multiplied by 3.680 into 10 power minus 3, the whole is squared, and this results in area equal to 4.2545 into 10 power minus 5 meter square. To find the resistance of 5000 meter long wire, substitute the values in the formula for resistance. R is equal to rho L over A. So R is equal to 1.720 into 10 power minus 8 times 5000 divided by 4.545 into 10 power minus 5. Now calculating all this results in resistance equal to 2.02 ohms. Question 4. Two resistors 15 ohm and 75 ohm are connected in series. If voltage across 15 ohm resistor is 60 volts, what is the amount of current passing through 75 ohm resistor? Given data is R1 is equal to 15 ohm, R2 is equal to 75 ohm, both connected in series. This is the circuit which will be formed by these two resistors with the voltage source here. voltage across 15 ohm resistor is V1 is equal to 60 because 15 ohm is, we have labeled it as R1. So the voltage across this resistor will be V1, that is 60 volts is given. Now you need to find current passing through 75 ohm resistor. Now remember and recall that there is only one path in this circuit, in a series circuit, there is only one path. So whatever current is taken out from the voltage source or from the power source, the same current, the same charge will flow throughout the circuit from all the devices. So in a pure series circuit like the one given, the current passing through all the devices is always same. Therefore, let the current be equal to I. Now, the formula V1, the voltage drop across R1 is equal to IR1. V1 is equal to IR1. Solve for I gives I is equal to V1 over R1. That is, we are moving R1 to the other side, and since it is multiplied here, it will be divided by the V1, and I is equal to V1 over R1. The solution. Substitute V1 is equal to 60 volt, R1 is equal to 15 ohm. So I becomes 60 over 15. Reducing this fraction results in 4 ampere. So 4 ampere current flows through 75 ohm resistor and throughout the circuit. It is 4 ampere even from 15 ohm, it will be 4 ampere from 75 ohm, and it is 4 ampere from the battery source as well. Question 5. You are given 3 resistors of 5 kilo ohm, 10 kilo ohm and 15 kilo ohm. You are asked to connect them in different possible combinations. Find the greatest and smallest resistance you can obtain. Now, resistance in a circuit can be connected in series, in parallel or in mix of the two. So given resistors are R1 is equal to 5 kilo ohm, R2 is equal to 10 kilo ohm, R3 is equal to 15 kilo ohm. In a series circuit, this can be connected like the one shown here, 5 kilo ohm, 10 kilo ohm, 15 kilo ohm. There is only one path that includes the power source as well as all the resistors. So this is a series combination. The other two combinations are, this one is parallel combination. All the resistors are parallel to each other and they have been connected in a parallel combination. This combination is mix of the two. These two are in parallel and this one is in series with these two. Now, the greatest resistance can be obtained by connecting all the resistors in series because equivalent resistance for resistors in series is given by the formula R equivalent is equal to R1 plus R2 plus R3, that is sum of all the three resistors, and that is the maximum value that can be obtained with these three numbers. Substitute the values. R1 is equal to 5 kilo ohm, R2 is equal to 10 kilo ohm and R3 is equal to 15 kilo ohm. In the above formula, R equivalent becomes 5 plus 10 plus 15. Adding them results in R equivalent is equal to 30 kilo ohm. Now you need to calculate the smallest resistance that can be obtained with these three resistors. The smallest resistance can be obtained by connecting all the resistors in parallel. So this is a parallel circuit, 5 kilo ohm, 10 kilo ohm and 15 kilo ohm. All are in parallel to the battery. In parallel combination, the voltage across all these resistors is V, the same voltage, whereas the current changes in each path. The resistor with the least resistance carries maximum current and the resistance with maximum resistance passes the lowest current, the minimum current. Remember. Now, equivalent resistance for the resistors in parallel is given by the formula 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now, substitute the values. R1 is equal to 5 kilo ohm, R2 is equal to 10 kilo ohm, and R3 is equal to 15 kilo ohm. That results in 1 over R equivalent is equal to 1 over 5 plus 1 over 10 plus 1 over 15. The LCM of these three numbers, 5, 10 and 15 is 30. So taking the LCM here, this becomes 6 plus 3 plus 2 in the numerator. That is very basic math. I am sure you all must be knowing it. Now adding all these numbers results in 11 over 30. So 1 over R equivalent is equal to 11 over 30. Now, in order to find R equivalent, take the reciprocal on both sides to get R equivalent is equal to 30 over 11. Now solve using a calculator, you get R equivalent is equal to 2.73 kilo ohms.